Okay, so welcome everyone. I'm Manish Agrawala, a professor here in computer science at UC Berkeley, and it's a real pleasure to be here today. I get to introduce one of my heroes in the field. More on that in a second. First, I'd like to say a big welcome to all of the web viewers that are watching this. This talk is sponsored by Infineon. And I also want to make a quick announcement that the Big Ideas deadline is March 19th for student proposals. And it's an opportunity for students to win up to $30,000 in prize money. So if you're interested in that, check that out. So we're here today because Professor Ben Shneiderman is visiting us. He's a professor of computer science at the University of Maryland. And to me, Ben is really one of the founders of not one, but two areas of computer science. He has done really foundational work in both human-computer interaction and information visualization. He has published a wide variety of papers in both of these topics, many seminal and influential papers on these topics. We discuss him in all of our classes in human-computer interaction and information visualization. Because of his work, I think he's been recognized by both of these communities as well as the larger community of computer scientists and scientists in general. I just want to mention a few of the awards that he's received. These are the most notable awards of many awards. Ben received a Lifetime Achievement Award from the Human-Computer Interaction community in 2001. He's been elected as a fellow of the American Association for the Advancement of Science in 2001. And he's so a ACM fellow. Most recently, he was elected to the National Academy of Engineering. So with that, thank you for coming.
Thank you. All right. Well, don't go. All right. Just don't go away. Just my appreciation of Manish, is for a lot of things, for his work also. And we had a wonderful week together in England at Oxford University at a conference where we spent just hour after hour talking about things. And I have a special appreciation for Manish, not only for his work, but he's the son of my dear colleague, Ashok Agrawala. And in appreciation of that, here's a copy, a gift for you, of this terrific biography of Einstein, probably the best biography ever written. So it's a sort of a symbol of great lives and inspirational lives and also big ideas. And I wish you well and enjoy it. And thank you for hosting me here. Thank you. All right. Well, I am very pleased to be here and appreciate that you're turned out here in crowds. And I hope it's for more than the food, too. But enjoy your lunches. And I hope I'll give you a little appetizing talk and some fruits of thoughtful inspiration. So as Manish said, I'm from the University of Maryland and happy to have been the founder of the Human-Computer Interaction Lab some 27 years ago, now run by Allison Drew and Jen Goldbeck and formerly by Ben Peterson. But it's a wonderful interdisciplinary community that's now run both by computer science and the rapidly emerging College of Information Studies, also with relationships to psychology, sociology, political science, and the wonderfully titled Maryland Institute for Technology and the Humanities, where we spend more and more of our time and have wonderful colleagues and projects. I enjoyed spending time with Ken Goldberg and seeing the new media center here and the activities that are going there. I think these are very fruitful, exciting directions that inspire computer science and the humanities. And these crossover disciplines are really, to me, a great satisfaction. I'm very much a child of McLuhan, and these kind of connections are great fun. You can visit our website. There are 450 papers, 200 videos, 40 pieces of software, and lots of other good things to take a look at. Over the years, we've tried to represent the idea of a scientific approach to the study, getting beyond user-friendly and trying to make a theory-driven hypothesis testing approach, specifying who are the users, what are the tasks, and then trying to predict and measure how long it takes for a specific user to learn a specific task. We want to measure the speed of performance on benchmark tasks and the rate and distribution of errors, their retention a week or a month later. Also, we understand the subjective satisfaction, the emotional content of these user experiences. And with Kent Norman, my colleague in psychology, we developed the questionnaire for user interface satisfaction, now in version 7, and with many competitors by now. But it had 110 items, from the little things like were the fonts readable, were the colors appropriate, were the words used consistently, were the sequence of screens in harmony with your task, was it easy to correct for mistakes, could experts perform more rapidly, etc. And the goal was to try to understand what made successful interfaces and why a novice might take 20 times longer than an expert to perform the same kind of task. And could we design better interfaces that accelerated performance, increased satisfaction, reduced errors? And it's a great satisfaction to see over these 25 years or more the progress in this field. And I've been an observer by writing this book. The 5th edition came out this year, but from its first edition in 1985 or 86, it traced the evolution of this emerging discipline. And here I highlight what was a remarkable observation for this 5th edition, which is that, collaboration was not enough, that the social media had suddenly, between the 4th and 5th edition, emerged as a huge topic, that YouTube barely existed. Facebook didn't exist. Facebook has now moved into number 2 in web utilization. YouTube has moved to number 4. These are, huge phenomena, and so that gets more attention. So here's a plug for my talk on Friday afternoon, 2:30, in the iSchool, which will cover the social media topic and the idea of converting or harnessing these social media to social and civic projects of national priorities like disaster response, health, energy, community safety, and so on. Today's talk focuses on the bottom, other observations of the growth of search as a central topic of HCI. You should rightly be proud of your faculty member, Marty Hurst, whose recent book called Search User Interfaces does a wonderful job of laying out the territory of the search issues and plots the course for the next 100 PhDs in search user interfaces. And our effort is focused more on visualization, and that's my theme today. Maybe I should lay out the territory here. We first tried to catalog what was happening in this book, which was a collection of 47 papers plus 60,000 words of our own writing with Stu Card and Jacques McInlay. And Stu gave the wonderful subtitle of Using Vision to Think. That is, your eyes are not merely an input mechanism, but the way we solve problems often is by the appropriate visual representation. And so information visualization emerged in the last 15 years as a large field accompanying scientific visualization, the more established, let's say, 50-year-old world. And I'll make the distinction between those. And our observation here was that human visual bandwidth was enormous, and our problem-solving and perceptual skills were remarkable, and that we were going to be looking at trends, clusters, gaps, outliers, relationships, patterns of all kinds, and they could be spotted in a few hundred milliseconds if we as designers got it right by using the retinal properties of color, size, shape, proximity, etc. And so, I would lay out the territory here as 3 challenges. The most common one is trying to get a meaningful display for massive data. How do I pack 1 billion records into 1 million pixels? Okay, how do I show that information? How do I see, even in this room with whatever, 120 people or so, I'd like to see, maybe show of hands, how many are in computer science or engineering? Okay, how many are in the iSchool? We should have 30 at least of Cecilia Aragon students. Okay, how many are from the new media world or architecture, literature? linguistics, psychology, business. What else? What did I miss? Graphic design. Thank you, Aaron Marcus. All right. And, you know, what I'd like is a kind of special pair of glasses to be able to look out and see not just the topics of your interest and what countries you came from, what programming languages you write, what natural languages you speak, what skills you have, where you live, that there's relationships that are rich and complex that have nothing to do with where you're sitting. There's no 3D, you know, positional reality, but you know, there are some interesting patterns here, and the exceptions of that one linguist in the room is pretty interesting. I want to be able to see that one linguist amongst the crowd of the 60 computer scientists and 30 iSchool people. Okay? So we want those great visual displays, and much of the attention in the field is about those displays. But I would say the field really has three central challenges. The second is designing the widgets, the control panel, and the coordination among multiple windows. That the way we see high-dimensional data is not by one picture that's scaled down or multidimensional scaling or some brilliant single image, but by multiple perspectives on this data that reveals the information we want. And getting the right set of dynamic queries and sliders and widgets and selectors to filter is really the central part. Now, often this is not so well shown in the images presented in the slick websites and so on, but equally important to the display is the control panel. Just like for the automobile, the engine's important, but so is the driver's, you know, driving wheel and control panel. The third part is the process model for discovery, and that's even less visible. And, well, let's say increasingly the tools we build have that process model made visual on the screen as a way of guiding you in, as I'll show, systematic yet flexible strategies that show you how you might do the kind of analyses you want. So that's really the challenge. If you want to learn about this topic, I'm happy to represent the wonderful work of Martin Wattenberg, joined later by Fernando Villegas and many others. Many Eyes, I guess it is now manyeyes.com as well, a much simpler web address where there are some 16 different visualizations. You upload your data, play with the visualizations, and then save it on the website, write a comment, and then others can comment on it, and then discussion ensues. And while they thought that, you know, this might elicit important national discussions of crime rates or political issues or economic issues, actually the World of Warcraft and Harry Potter and other pop culture things turned out to be what really people wanted to look at. Just a further introduction to suggest that this has now matured, that those startup ideas that came from university projects on this campus, on our campus, and Stanford and elsewhere, Carnegie Mellon, morphed into these startup companies, which then got bought by the middle-sized companies, and then those middle companies got bought by the bigger companies. And there's maybe more, there's probably many more to add to this, but I've had the pleasure of following through the Spotfire process for 10 years, which was the result of our work. The paper originally in 1994 with Chris Olberg at the CHI conference resulted in Chris forming the company Spotfire in 96. The product went out in 97 and grew to 200 people by 2007 when it was bought by Tibco. This is one screen from it, and it's one of those rare moments when a single screen captures a moment of discovery. This is Nick Thomas from GE in England, and this was the discovery that the RBP1 gene was far more active. That bright red spot was totally unexpected, and that was significant, and that's replayed here in the plate map as well as in this 3D representation. And all of that was obtained by setting the right sliders, filtering the data in an efficient way so that you could see this unique phenomena. And that was important because RBP1 plays a role in the formation of retinol in your body, which in turn plays a role in embryonic development and vision. I'm not going to go into Spotfire, but just to say my great satisfaction to see how that tool has become a great widespread success. How many have used Spotfire or seen Spotfire? A small number. They are, a widely used high-end tool. All 25 of the leading pharmaceutical companies use it for drug discovery and major use in genomics and spread to many other industries. Here you see Spotfire in use with 27 windows open to be able to look at this complex data set by a group of people. And Spotfire incorporated, I guess in the slide I showed here, this principle of multiple windows, of multiple displays, coordinated so that a change in one window, that is by brushing and linking, produced results in other windows, and the dynamic query sliders that would let you filter and select at the, at a million, having a million records and still do 100 millisecond updates so that you could get this rapid, incremental, and reversible experience of exploring the data. These ideas have, become more and more appealing, and people are going for larger and larger displays to 100 megapixel displays and beyond, and also down to small displays. And these visualization tools get embedded in many practical things. It's not that I want my air traffic controller or radiologist to do their work on an iPhone, but sometimes it's a good way to get things going. Okay, having more pixels helps. Okay, so what we learned from those first 10 years was a few lessons, and I want to summarize, and then I sort of want to go on from there. And I wrote this down. Each line represents one project where we struggled for weeks or months to find the right design, and this is what it proved to be. So I wrote it down for myself, and in a playful paper, I wrote it out 10 times in the paper this way and called it the mantra, and it somehow stuck. There are more than 1,000 papers that cite this. There are people who extend it, people who contradict it, people who joke about it, so it's kind of fun to see how it's traveled. But the principle suggests that you, the user, get to see an overview first. You start by seeing the entire data set, where it is, where it isn't, how much there is. Okay? Then you, the user, zoom in on what you want, filter out what you don't want, and then click for details on demand. And I think what's attractive about this is it does provide a rough kind of pattern in the Christopher Alexander sense of how to design. It can be interpreted in many different ways, but it dramatically asserts that discovery is made by people, and that we build powerful tools, and that the user gets the overview. The user zooms in, the user filters out, and the user clicks to get the details on demand. And so we become more and more absorbed with this process model. This may be our first attempt at a process model. It's kind of simple, but I think the maturing understanding that we need to guide users and give them the tools to let them work through more than just a single step. So the second observation I make here is the strong separation I've alluded to between information visualization and scientific visualization. In scientific visualization, this more mature field, there's a left and a right, an inside or an outside, an east and a west, a north and a south. There are directional things, and what you're looking for is where does the turbulence maximize on the surface of the wing, or where does the cholesterol collect in your heart? And these are important and remain important questions. But InfoViz has taken on new territories, multivariate data, higher dimensional data. Spotfire is an example there. There are other good commercial tools like Tableau, which is the result of a Stanford group, GGobi, TableLens, and hundreds of other university projects. I'm going to look at temporal data briefly and talk about some of our work there. We'll talk about trees quickly. And then close with some where we are about network data and hope to inspire you that way. I guess I should ask, was there a handout sheet? Is Yvette here? There should have been handouts with all the URLs. Yvette, there should be handout sheets with all that information so I see people taking notes, or if you have, maybe you could pass them out just so people could make notes on that. Is that possible? All right. So I start with a project, and this is the PhD work of Harry Hochheiser, Time Searcher, was what we called it. And here we start by looking at a very simple data set. It's 13 months of data. It's 223 stocks. And they go up and down, and they jiggle around, and some are flat, and some are sharp, and so on. So I guess I come back to you and say, do you see any pattern over here? Anything interesting?
The open space.
The open space?
Sort of open.
Peaks in February. I guess that's what catches my eye. You have to train your eye a bit to learn these things or look at it. But I see a high volatility in February, and that's what draws my attention here. So I select our time box, and I look at first the peak. And if we select the peak there, we get, there's two observations I would make, that every stock that rose in February fell back in March. Okay, so it was an interesting pattern. But there was one anomaly. Adaptive broadband rose ahead of everybody else in January. Now, that's pretty interesting. And a lot of people in the genomics field and in stock market analysis are interested in these things. There's many tantalizing problems around it. I guess the one that's most chilling is the September 11th, 2001 was a Tuesday morning. And do you recall which company's airlines went into the World Trade Center? Thank you. So, and the Thursday before, American stock doubled in volume and dropped 10% in price. Okay, it's a pretty strange anomaly, and it's never been tracked as to where that went and why that happened, but who may have known? So these things don't tell you cause and effect, but they tell you where to look. And so that's sort of an interesting observation, and there are many others. And we could look at the bottom, which is not as sharply defined, but there's some interesting points there. Or our genomics friends and our stock market people ask the same question, like, what starts low and finishes high? So, we can help them find that and explore this way. Or, we could help them and say, what are the stocks that start low and stay up? We don't want the ones that are volatile. Let's see, we got a little tight fit here, so let's see if we find a little more space, get a few more. There we go. So we can begin to play with this, and we can take this pattern, and we can go hunting with this pattern over different parts of the year. And then we can say, as our stock market and our genomics friends, they said, what goes the opposite way? And so we built this little flipper, and so you can find those things. Now, one of the reviews of this paper from a data mining person was, nothing new here. You can do all this with SQL. It's less than this and greater than that and less than this and greater than that. There's nothing innovative here. I can understand that argument. On the other hand, the fact that we can move these around, if you tried to write this, it's about 40 lines of SQL, which would take you about 100 seconds to write. And since we can change it 10 times a second, I would claim this is 1,000 times better than SQL, or faster. And so, we've gotten that kind of warm response for these kind of tools. Let me just pause here. Any questions about what I'm showing you here? Just to give you an idea, just the principles of rapid incremental and reversible operations, immediate display of results, that output becomes input. The place where you display data is the place where you also input your search criteria. These are the widgets that we control it with. Any questions about this? The design parameters, the computer science side, was to get about 200 time points, but 10,000 stocks, or 10,000. So that's a fair amount of data, and to keep the 100 millisecond update was a good challenge. And here we faced that problem as well as in Spotfire, and in both cases we found that traditional, after 2 years, with the traditional data structures of grid files, KD trees, and quad trees just didn't work for these higher dimensional structures. And so we developed these rapid in-memory search strategies that rapidly cycle through these and do these kind of searches in a quick way. Okay? There's a lot of other features. This is free to download, a time searcher, our website. It's on the handout there, so you can take a look at that. But just wanted to give you the flavor of that. Chevron came along and said to us, that's great, but 200 time points is not quite enough. We have the time, the pressure and the temperature in every well at the top and the middle and the bottom every 10 seconds for a year, and we've never been able to see the data. So we built a version that does 10,000 time points, and we then allowed richer kind of searching, and this looks at 5 years of weather data, and you can select a pattern or a shape. This is 2 cloudy days with 7 sunny days in between, and then it will find similar patterns where these triangles are, and you can control the sharpness of the search function and the, to determine close matches or far matches. This orange rectangle is the zoom box that shows you what this detail view is all about. So that's just, like 2 months worth of data out of the 5 years, and it's spread out here. Of course, usually on a 1,000 pixel wide display, you can't see 10,000 time points, and so we have these compression strategies, and therefore you need to zoom in to be able to see the details. Okay? So these are numeric data, very common, and we're pleased many people have picked this up. Time Searcher 2 is also free to download from our website, and there's a Time Searcher 3 that does forecasting as well, so you can take a look at that. We became more interested in other kinds of temporal data, which in this case we call them categorical or event data. This was a 1996 effort to design a single screen view of a patient history. Our design goal was a 100-year patient history with 10,000 medical events. At the top we have the physician visits, the hospitalizations. These are lab tests, medications, and other treatments. You click on the sonogram, you see the sonogram. There's the fetus. You click on the x-ray, you see the x-ray. So these were all zoomable, filterable, and then you click for details on demand. So the principle was applied there. And here you're looking only a 3-year period. At the very end, this today timeline shows this patient is currently pregnant and expected to be pregnant for another 2 months. They have been diagnosed as being diabetic. They've received insulin, an increasing dosage of insulin, and then Lasix to counteract the side effect of that higher dose for pregnant women. Okay? So for the physician looking at this, and it takes a little training to get this idea, this provides a rapid overview of the history and also the current status in one screen and provides filtering capabilities. Okay? We're pleased that about half of the current electronic health record systems have something like this or derived from this built into them. But even then, we were eager to go beyond looking at one patient, because one of the powers of the computer is the scalability to get to millions. And so we finally began to work on this project of LifeLines 2, which then lets you look at each one of these gray bands. I can't quite see it here, but each of these is a single patient here. And I'm going to show you a 4-minute video that shows you the features of the tool built. It's the current PhD work of David Wang. This is a rather complex thing, so you'll watch carefully, but let me just show you the situation. These are patients who are injected with radiology contrast to then look at their blood flow through their kidneys. Now, unfortunately, about 7% of the population have an adverse reaction to this radiology contrast, and therefore they need to be monitored. So they're given a test for their creatinine levels before the test, 2 to 4 days, I think, and then they're given a test afterwards, and those who have an elevated level of creatinine are the ones that they're worried about. So finding those patients is a challenge for our physician friends at the Washington Hospital Center. And here is David Wang's story about how we worked on that.
In this demo, I'm going to show how to use LifeLines 2 to find patients who experienced decreased renal function, possibly as a result of the administration of their radiology contrast procedures. This is indicated by their creatinine high events within 2 weeks after a radiology contrast. Here I have loaded a data set of 3,598 patient records. Each record is represented by a horizontal strip containing the patient ID and the events in the patient's history. Each event is represented by a colored triangle on the timeline. From the legend, I see that creatinine high, normal, and low are in red, blue, green, respectively. Scrolling down, I see that radiology contrast events are in yellow. To examine this data better, I align the patient records by their first radiology contrast events and rank by the number of creatinine high events to bring the most severe patients up top. I immediately realized two things. One, some patients have chronic renal deficiency and they should be removed because their condition is not related to their radiology contrast. Two, some patients have more than one radiology contrast event, and this needs to be taken into consideration. To remove the chronic patients who have at least 4 creatinine high events prior to a radiology contrast, I choose to filter by the number of occurrences on creatinine high. I set the number to be at least 4, and the filter scope to be before the alignment. The blue highlight indicates that these records are selected. For our purposes, we want to remove them. I click on Remove Selected and also save the remaining records as a new group. It's called Non-Chronic. Next, instead of aligning by every patient's first radiology contrast, I align by all radiology contrasts in all patients. LifeLines 2 asks me whether I will proceed, as some patients will be duplicated. I click on Proceed. Then I bring up the distribution of creatinine high events across these records and zoom into the granularity of days. As I drag from day 1 to day 14, I'm selecting all patients who have at least one creatinine high event within 2 weeks after any of their radiology contrast events. This time, I will click on Keep Selected and save these records as another group. Let's call it Candidates. Looking at this group, we see that this is more of an overestimate. Many of the patients do not exhibit patterns of contrast-related renal deficiency. It would be better if we restrict only patients who have a baseline of normal creatinine prior to their radiology contrasts, without creatinine high events in between. To do this, I will use a sequence filter, specifying only for patients who have at least one creatinine normal reading, followed by no creatinine highs, followed by radiology contrast, and finally followed by at least one creatinine highs. Likewise, I'll click on Keep Selected and save this as a final group. Finally, this gives us 157 records. And visually scanning this group, these patients exhibit more prominently the patterns of contrast-related renal deficiency. And this concludes our demo.
Okay. Any questions? Well, let me make some comments here. So I hope you got to see this, the process model, the align, rank, and filter, and summarize were the tools that were built in there. And by combining them in effective ways, David was able to, this is a genuine case that our physician friends really were very excited by, trim down from the 3,600 down to 157 that are relevant. And so we've been exploring how to make this comprehensible to the physicians. And we find it takes actually several weeks of working for them to begin to restructure their thought processes to think of queries that have temporal patterns in them. So that's one of the dramatic benefits of visualization tools, is that it helps restructure people's thought processes and problem-solving strategies. My second point is that actually this produced a large number of computer science challenges in here. The algorithms for doing this rapidly at scale resulted in a paper that will be published in IEEE Transaction on Knowledge and Database Engineering. And so it actually resulted in more rapid search strategies than traditional string search strategies, and also accommodated the varying time distances between these categorical events. So we find that these visualization challenges bring us many new basic database and algorithmic challenges in computer science. Let me just pause. Any questions about what I've shown you here? If you have temporal data or categorical data like this, we'd love to hear from you. This is still under development. His dissertation will be defense will be later this spring. We're happy to work with people and share that, but we're sort of not yet ready. This one's not polished enough to post yet on the web. But we think this opens up a lot of new territories for important kinds of data. Weblog analysis, we've analyzed student histories, a lot of temporal patterns and histories become accessible under this strategy. I guess there's some more there. Let me move on to tree structures and the work on tree maps. This was our tree map algorithm, or there's actually now 5 of them, but you can download this for free. And it was a way of representing hierarchically structured data. Here, the 14,000 nodes in the gene ontology at 23 levels were doable in our environment. We were delighted that Martin Wattenberg made this a popular story when he put out Smartmoney's MarketMap in 1999. I was a consultant for them. And this shows 11 industry groups on the stock market, about 600 stocks. And the green ones are rising, the red ones are falling, and the area indicates the market capitalization. So you can see Microsoft's one of the larger in the technology sector here. So this gives you a sort of typical day of ups and downs, but here's a particularly interesting day. Anybody see anything interesting? Little green. You said no green. There's one lonely green. Doesn't that jump out at you? It jumps out at me. I can't help but seeing that. But that day was pretty remarkable. And it wasn't just a little green, it was bright green. And when I clicked on that one, it turned out to be the AMP Trading Company, which that day had bought the Pathmark chain of grocery stores, and it rose 5% when everybody else was down. So it's kind of amazing to be able to spot these things, and once you become familiar with the structure and the layout, and you come to know that the gold stocks are over here, and the defense stocks are over here, and you can see they travel in certain groups. On this day, the energy stocks were generally up, except for this was ExxonMobil, which was kind of flat, and the technology stocks were up, but financial sector was down with a few exceptions, and healthcare was down with one dramatic bright green exception. So being able to tune yourself to these clusters and groups and exceptions and outliers becomes a really powerful way of trying to understand data. And if you like good news days, that's what good news looks like, except for a few thens that don't. The N's indicate that there's a news story. If you click on the N, this is free to go if you at the Smart Money website. The N will tell you a news story about that website. And if you click on any one of the boxes, you get a mountain of data, 20-year trading history, insider trading patterns, business reports, et cetera, et cetera. Okay? Many people have picked up on this. It's one of the great pleasures. This is a wonderful work of a 26-year-old Argentinian named Marcos Westcamp, who built a tree map called the News Map, which shows the world's news, 20 countries, and the area indicates the number of stories about that topic, and they're organized by, world news, national business, technology, sports, and so on. I work with the Hive Group, which has licensed our software, and this is one of their supply chain management projects for the Marine Corps. Every T-shirt and tank is monitored by 3,000 people who use this every day. The red boxes either are shipments that are delayed or had a high failure rate or had some kind of problem that deserves attention. And the tree maps have become sort of a common culture thing. New York Times here showed a very intense dimensions of data about the truck and car sales in the U.S. and around the world. They now regularly use tree maps for a variety of applications, and tree maps have appeared on the television show 24 and other kind of places. So it's kind of satisfying to see an idea go generally. And for scalability, this is a million node tree map of all the folders on all the servers in the computer science department of Maryland. This big gray area was a surprising area of ungarbage collected data, about 7% of all the data that had been sitting there for years and nobody knew about it. There's lots of stories in here. I think you can see dramatically 3 copies of a very large directory over here that nobody knew about. There's actually 6 copies of another directory here. And so you can get tools for free from the web to look at your own hard drive. And our free tool also lets you look at your own hard drive. Okay, so I move on to the last topic. And there's lots of good work about trees, but I think it's still a very important topic to look at. But I wanted to save a bit of time for our current work on network visualization. Our 2 efforts focus now on the electronic health records as our main effort and the network visualization. If you're interested in the topic, Manuel Lima has compiled a list of some 700 different network visualization tools with a link to all of them, and they're often very colorful, very wonderful pieces of art. In fact, he has a poster with all the swirl of nodes and edges and so on. But I think we can do a lot better, okay? And I've been pushing to look for better ways to represent the data, and this is Adam Perer's PhD dissertation on social action, where we put together the ideas of systematic yet flexible, and there's a sort of guiding structure of all the things you can do, as there was on the right-hand side with the LifeLines too. But it walks you through and shows you what % of the possible operations you've executed here. So you can see that you haven't done any of the edge evaluation metrics at all here, and so there are some opportunities for you to go further. What I'd like to show you is this remarkable demo, little 1-minute video of social action in action. And this shows the patterns of voting in the 2007 Senate year. The blue senators are the Democrats, and the red are the Republicans. Every senator is connected to every other senator by a link. So there's some 5,000 links that we're looking at here. So it's quite a large tangle. And the strength of the link indicates the number of times they voted the same way. So there were about 330 votes, and the maximum number of similar votes was 303. And so that was the way we began to do the filtering. So I'll start this thing running, and we begin to filter out the 110, 120, 130, 140 similar votes, 150. John McCain, who was out campaigning for president, was not connected to anyone, and he sort of spins off. And now this remarkable, too good to be true, unbelievable visualization emerged. You can see Brownback, who was out campaigning for president, also drifts off to the side. And I'm going to stop this video right here. And you get this unbelievable, I never would have believed it. Just to comment, these 2 independents show up here, Lieberman and Sanders. And you get a complete partition of Democrats and Republicans, which maybe now seems obvious, but it did not seem to me that there was such a separation. And then in the middle are 4 Republicans who sometimes vote Democrat: Olympia Snowe, Susan Collins, Arlen Specter, and Smith. And what do you know? When the stimulus bill in January 2009 was voted on, 1, 2, 3 Republicans voted for the Democratic-sponsored bill. And what do you know? Arlen Specter switched parties and became a Democrat. So, again, we don't want to say these visualizations tell you about cause and effect, but they show you things that may be informative in understanding patterns of behavior. You might also be intrigued to see that furthest from the Republicans are Christopher Dodd, Joe Biden, John Kerry, and Obama over here. Mikulski also. So they're way out on the edge further away. Okay. So this was brought to us by the journalist Chris Wilson with Slate magazine, who's been wonderful in looking at network analysis and done a number of great articles that have deep, good computer science stuff in it. And last week, his remarkable 5-part series about the social network that was used to capture Saddam Hussein. This was, I'm proud to say, a University of Maryland story as well. Major Brian Reed in the Army compiled the social network of Saddam Hussein. And it became his PhD dissertation under Professor David Siegel at Maryland. I have that on my laptop, and the entire social network of Saddam Hussein then led the investigators to Tikrit, where they captured him. This was as opposed to the efforts of the Defense Intelligence Agency that published the deck of cards, the 52 cards, which were his aides and assistants while he was president. But those were not the people he could trust or go to once he was out. Once he was out, he went to his social network, to his family. And that's why he wound up in Tikrit. And the story is that that's how they wound up capturing. It's a great, his journalistic report, by the way, is exceptional and readable. And then if you want to track down Brian Reed's dissertation, a worthwhile read as well. Let me just go on here. I think I've got a little bit more time. And just show you one other interesting phenomena for the 2007 Senate. We go back and... what's that? Yeah, it could be. We freeze the topology now, the Fruchterman-Reingold layout, and now we continue to filter out edges while the topology's frozen. And then what you get is this revealing portrait that shows that essentially Republican Party loyalty and cohesion falls apart, except for Chambliss and Isaacson over here, whereas the Democrats still have their party cohesion. I guess it would be fun to look at what this looks like now or what it looked like in the past. But these things are so compelling and revealing. I find it, we couldn't believe how good this one turned out. And even, we didn't set it up, but the Republicans moved to the right, and the Democrats moved to the left. It just all was too sweet to be, too good to be true. Here we are. Well, let me just briefly comment that the trick was, how do you evaluate a tool as complex as SocialAction with so many features and so many weeks to learn? And we developed a strategy of case study analysis, and we would work with professionals on their own data. In this case, Chris Wilson was the one we saw here. 2 to 4 weeks where we'd work closely with them, help them intensely, and then 2 to 4 weeks of mature use where they worked more on their own. An exit interview, and so we had a structured approach to it, and so we think we are looking towards these strategies of long-term, multidimensional, in-depth, long-term case studies, or MILCs as we call them. I don't want to, that's a whole other talk, but I wanted to close with a few comments about NodeXL, the current effort, free to download. One of the handouts should have a page about that. You either type in your network in Excel, or you load it in, just a edge list, and then it will draw, and you have rich controls for setting variables and labels and so on. And that's what the Senate, you can download the Senate data set that I showed you there, and this is what it looks like in NodeXL. And you can go into the spreadsheet side, change values, set colors or other things, or use our dialog boxes to autofill the columns, to set color, all the visual properties of and the size and color properties. And I just want to show you a few of the examples of things this is a set of things my students did in a 2-week segment of their visualization course. So they downloaded the data from the data.gov, the open government website about visits to the White House. These are the visitors. These are the people they visited. The thickness tells you how many times they visited them. Standard bipartite graph shown in a quite nice way. This was a Senate co-sponsorship network. I don't know how well you can see it, but Ted Kennedy has the most incoming arrows. Everybody seemed to want to co-sponsor with Ted Kennedy. The size of the picture indicates the number of bills they sponsored. So Hillary Clinton actually sponsored more bills than Kennedy, but had fewer people who were ready to co-sponsor with her. So these begin to reveal patterns of groups of people who work together, or those disconnected components of those who don't work with the others. And that's one of the nice things you can do with NodeXL, is these rich dynamic query filters that let you sort things out. Another student project looked at the voting patterns in the United Nations. The U.S. and its small number of allies at a certain point, or were here, and then the European and Russian blocs. When this was in the 70s, different strong and weak relationships between different blocks of voting countries. In the book that we've just finished and submitted yesterday, should be out by June or July with Morgan Kaufman, we have, we explain NodeXL and we teach it, but then we have a set of chapters of application. So on Wikipedia, Flickr, YouTube, and NodeXL has importers for all those social media websites, and this one shows a Wikipedia discussion for a certain article. The size, the red nodes are the ones who had most confrontational, and the size of the number of discussions. But you can see the separation into 2 or maybe 3 subgroups, and this person, Charles, is sort of the bridge person who goes across both of these discussion groups, and you can see the strength of their argumentation and how closely or not people work together. This is a great story that Marc Smith, one of my co-authors, did from, there was an NYU conference last year that had about 70 people, and they were asked to tweet about the conference. It was, the hashtag was WINO9, and everyone in the room apparently felt there was a separation between the sociologists and the computer scientists who weren't talking to each other. And sure enough, Marc found the Twitter network was really separated quite strongly. In fact, these are the sociologists. The number of followers of each person indicates this by the size of their photo. And then there's one bridge person who was talking to both sides. But it's pretty dramatic to find these kind of communities and look at the strengths of connection and who's connected with who else. So I'll let you look at those. This was a Flickr network. If you search on the tag mouse, you find actually 3 connected components. I don't think you can see the labels there, but I put them here. The animal, mouse, is over here. The computer, oh, I got that backwards. I'm sorry. This was last night's hasty addition. This is the computer bunch. This is the furry animal, and this is Mickey Mouse. And they form separate communities of tagging. And in NodeXL, you can download the networks by tags or by people and look at who comments. I think I have that here. This is Marc Smith's Flickr network, and these are the people who comment or tag on Marc Smith's page. There's Marc. You can see me. I occasionally tag or comment on his photos, but these are other people. Esther Hargitay at Northwestern, for some reason, loves to comment and on Marc's photographs, and you can spot those kind of things. These are, some of these are families, and the others are professional circles of people who comment and tag. So I'm closed here with the process model argument. Various people have described as sense-making loops. This is in the book by Jim Thomas and Kristen Cook on visual analytics. This is a very simple model which says you gather information, you re-represent it, you develop an insight, and you produce results. A little bit simple and naive. This is a more elaborate one from Stu Card and Paroli about the complex pattern, and I'll just sort of close by saying the takeaway messages are that I believe visualization supports discovery in a rather remarkable way. For me, it's heartening to go to the Spotfire user group meetings and hear people like the head of Monsanto say, I'm a statistician who's been working for 20 years, and this changes the whole way our 3,000 scientists and engineers work together in terms of doing discovery. That the opportunities, I think, are in multivariate data, temporal tree data, network data, and that once you've made a discovery, that network and these visualization strategies are a strong way of communicating those results and conveying the importance and related features in those results. And the remaining challenges are just what I opened with. How do we create meaningful visual displays of massive data that shows clusters, gaps, correlations, outliers, etc.? How do we build the interaction widgets and coordinate the windows effectively? And the current effort of what is the process model for making discovery more than opportunistic? How do we make it more systematic yet flexible? Okay? And that means the integration of statistics with visualization. That is the data mining, the statistics, machine learning, and the visualization. I'm really eager to see those joined. I'm saddened that the data mining community has moved away from visualization, and I hope that we can rejoin that, in a better way. Support for annotation and collaboration is one of the strengths of Spotfire, and then look for the idea of preserving history, having undo, macros, replications, etc. Those are sort of the basic ideas. And, put it to good work. And I just close with this, that, there are many problems we can work on. I'm delighted to be here in CITRIS, and the vision of CITRIS to, apply technology to human problems is something that I think is quite wonderful. And, here is, if you want a challenge, work on these 8 Millennium Goals of eradicating extreme poverty and hunger, reducing child mortality, combat malaria, HIV, AIDS, and other diseases, ensure environmental. That's a list that we in computer science should embrace. And I find most computer science students and faculty are unaware that in 2000, the UN, the nations, developed this. And sadly, 10 years into it, progress is very slow. We can help. Our technologies can be put to work. We should make that effort happen. Thank you. And come visit us on the web or at our next symposium at Maryland in end of May. Thank you. Appreciate it. Thank you. And I see there's a microphone, so I know some of you have to rush out, and thank you for Cecilia Aragon bringing your class, and you may have to run out, or others have classes, but I'm happy to stay for those who can. And thank you. Aaron gets the first.
Ben, you made an interesting comment early on about culture as one of the areas of interest. And I'm wondering if you've looked at even culture bias in your strategy for how people initially search, because I was struck by the way you described it. First getting an overview and then zooming in. There have been studies done which show that Asian and Western people look at websites in completely different ways.
Yeah.
And it might as well be applied to all data observation. And then, at the end, to be developing templates or approaches that are culture sensitive for the way people, in fact, think and search.
Yeah. Well, Aaron, you've been a great promoter of us thinking about outside of our own way of framing problems. And I think your argument is valid. I mean, we have not looked at different cultures. I guess we think of the cultures as the cultures of physicians, versus the cultures of business people. So there's many dimensions of how people differ. We find the kind of problems they're after are also dramatically different. I think we are very aware, as I alluded to, that these tools change your mind. And it's like, getting glasses. Suddenly you can see things. Getting a telescope, a microscope, an X-ray, a CAT scan. Those things open up many, many possibilities. So are there culturally different ways of looking through a microscope or a telescope? There may be. But it's such a profound shift and we're still absorbed with that first order effect of just getting people to change their way of thinking about problem solving. And I think you're absolutely right that the cultures of different disciplines or different countries would be a further, refinement. Bravo, let's do it. Others?
Any other questions?
Yes, I see here a couple of hands. Yeah.
Oh, sorry.
Just from the presentation, which was great, it looked like you're always dependent on an expert looking at what things that they should be screening on and filtering. is there anything that stops the computer itself to try and figure out what kind of displays you think are interesting displays and they should be made aware of?
I have a strong orientation as a designer to building tools that empower people. And when we want a high degree of automation, but we want, as we increase the automation, we want to increase the user control. Because for me, the central issue is responsibility. And if I make the machine become this automatic detector, I think I'm undermining the responsibility of the user in making the discovery. So we're very attentive to that issue, and that's a long discourse. But our approach has been to provide powerful statistics to show you where to look and to shift from, I'm sympathetic to your point, to shift from opportunistic towards systematic approaches. But I would say I'm always into making that in a condition where the user gets to understand all the possible options and then they choose. And I get troubled when the machine takes over or the AI models suggest that you do this stuff. I mean, I want to build the statistics in there, but I want user control. Do you want to respond to that?
One problem that seems to be in what you presented along those lines is you may be an expert in, say, your political science example. But if you were to redraw the map and you did it in terms of votes for people who were in districts that were highly Democratic, but they were Republican, how does that change? Right. And that may be something that you're not aware of and is not in the inputs that you have. So you could have, help the person by bringing in other databases that they're not aware of.
Absolutely. I mean, there's two comments there. First of all, domain knowledge is essential. This can't be done, without having intense domain knowledge. And in every project I work on, having more data sets to then explore, link to, and correlate with become essential. And the tools should facilitate that. I mean, certainly Spotfire early on, one of the first things we did was make it clickable so that if you have a chemical compound, you could click on it and go to a chemical database and get the information about it. And linking to genomic databases and weaving together multiple is a continuing issue. So yes, I support that idea of multiple databases. I think the interesting issue is what degree of automation. It affects another point that you were alluding to, which is the degree of expertise necessary. I mean, our focus has been on physicians and expert users in their domains. And we're aware, and that's why I mentioned Many Eyes as such a wonderful opportunity, because it opens the possibilities to more and more people. And that's why efforts like Many Eyes and the New York Times, which I've worked with and tried to encourage, their tools are more than just static visualizations. Increasingly, they're providing data sets and supporting exploration by their readers. And that's a very powerful movement, too. Yet you have to keep the level of complexity in a way that someone understands what they're doing. Because just random clicking like a video game could lead you into very dangerous places with the data. So we want to make sure people know what they're doing. Okay, I see. Oh, yeah.
I was curious what your views on the role of design aesthetics in visualization tools and the visualizations themselves.
Mm-hmm. I'm all in favor of aesthetics. I guess we work with designers at times. We don't always get beautiful ones, and choosing color palettes is an extremely important one. We're great fans of, what's her name, Cynthia Brewer's Color Brewer, and learn from that kind of method. We try to make things that look pretty, but our central goal is clarity, comprehensibility, and so on. So I didn't get to it in this talk more, but I talk about, like I had the information-seeking mantra, I've also described this net viz nirvana. And I'm a real enemy of those great swirls of nodes and links and great color and these hairballs of things or spaghetti bowls of things that are commonly shown with great pride and make the front cover of magazines and even the New York Times. And that great swirl is, to me, an example of failure. Okay? So for me, the principles are every node is visible, that is no occlusion. Every label is readable, similar, that you can count the degree of every node, you can follow every edge from its source to its destination, and you can see clusters and outliers. Okay? Now, that's very hard to attain, nirvana, as we know. Very hard to get that. But I use that, and the examples I showed you from NodeXL were chosen carefully because they're real simple. They're real clean. You can see every edge. And you know, we've been in this debate now with the publisher about what to put on the cover of this book. And the artists want these great swirls with color and lines and everything going. And I'm saying absolutely not. If anything, what we represent is the idea of clarity and being able to understand every node and every link. So I've had this, you know, with processing. Ben Fry has, you know, he's been arguing for an aesthetic view and sort of aesthetic backgrounds and things that animate and move and, you know, that are colorful and so on. And I'm, you know, if you're putting it in a museum and your goal is aesthetics, that's fine. If your goal is discovery, I would say that those things are potentially counterproductive. And so you may have read Stephen Few's blog critiquing Ben Fry's processing, a particular application for GE Healthcare, and I absolutely support those things. So we're getting a sharper understanding of what works and what doesn't work, and maybe we're emerging with an understanding of when purely aesthetic values are appropriate in museum or other things, and when clarity and comprehension need to dominate. Can we get both? Well, you know, it'd be nice. You know, we try. And if you have suggestions, we are always trying to learn better to how to make aesthetic as well as comprehensible. Do you want to respond to that? Is that?
I completely agree.
Okay.
Getting both is extra hard.
Yeah. But, you know, these backgrounds of, you know, stuff are distracting, and these blurred and animated things and things bumping up and down, visual thesaurus is, you know, a real loser, you know, these things that jump around and jiggle and wiggle, and they're just not helpful. I mean, the evidence is...
necessarily be visually complex equals aesthetic. Or it seems that there is this division between engineers and artists, that artists want to make it beautiful for its own sake, engineers want to make it work. What I would like to see is sort of people in the middle who can take sort of this aesthetic qualities and apply them to functional, discoverable tools.
Yeah, I think that's absolutely right. I mean, there's the scientist in me maybe also, which wants to have an evidence-based approach for making those decisions as well. I don't want to say it looks nice. That's why, for example, in the network analysis world, there's a literature, about 100 papers on the aesthetics of graph drawing. I'm not interested in the aesthetics, and they're talking about aesthetic metrics, and we're working on that, and there's a PhD student whose thesis was, but we've had to redefine the words, and we don't use the word aesthetic. We're talking about readable, comprehensible. We talked about quality, but that was a little too quality metrics. That's a little too ethereal. But readability metrics, and we now have 14 of those that tell you whether and they're not subjective. They're pure. How many edge crossings are there? Okay, how many occlusions are there? How many tunnels are there? A tunnel is when an edge goes under a node, but it's not connected to it. That's really like bad design to me, and I want to get rid of those. So we count the number of those violations, and our goal is to develop algorithms that reduce the number of those. So I want an evidence-based approach that shows performance improves when I have better metrics. That's the way I work, okay? Now, if I add in the right color and shape and so on, and I'm always aware of symmetry, balance, and the usual things that I want to make look nice, too. So I think we're in agreement there. Manish?
Well, so I think we're unfortunately out of time.
All right.
But join me again in thanking Professor Shneiderman.
All right. Thank you. Thank you.